Now we're going to look at how to do this with rationals. Remember, rationals are fractions. Rationals are a little different. So, do you remember what's special about rationals? Have like blah over mic. What's critical about this thing? What's the thing we always worry about with rationals? Do you remember, or maybe? What's the deal with the number down here? Whatever's down here can't be 0, right? We can't divide by 0. Alright? So we're still going to solve these basically the same way, except over here I'm going to modify my strategy a little bit. So I'm going to say, see where it says find where the function is 0? I'm also going to add, I'm going to say, or where the top is 0 and the bottom is 0. Oops, you can't see that. So I'm going to see where the top is 0 and where the bottom is 0. I'm going to treat each of those separately. And instead of doing this, I'm going to do those two in a little red. So I'm either going to find where the top is 0, and then I'm going to find where the bottom is 0. Then I'm going to do pretty much the same thing with a tiny little exception. Okay. So let's look at a problem, example problem. So say we've got something like 3x plus 3 over 2x minus 4 is greater than or equal to 0. So what I want to do is I want to find where the top is 0, and I'm going to find where the top is 0, and I want to find where the bottom is 0. I'm going to treat each one of those separately. So I want to know where is this 0 and where is that 0. So stupid cord in the way. There we go. And that makes me happy. Sorry. If you get annoyed by small comments, this class must be hell. Plus 4 plus 4, 2x equals 4 divided by 2, and x equals 2. Alright, so now that we've done that very exciting diversion, now on the top, you're going to follow the rule of the sign. On the top, you're going to follow that rule. So when I ask, am I going to include this or am I going to exclude this, what you're going to do is you're going to look at that and decide, okay, am I going to include it or exclude it based on that sign? So remember, this is greater than or equal to, right? Greater than or equal to. Come on. Greater than or equal to. So am I going to include this point on the number line? Yes, right? I'm going to include it because it's greater than or equal to. But what about this point over here, the one on the bottom? Am I going to include this point on the bottom? Well, if you just looked at the sign, you'd say, sure, of course, right? But remember we said something a second ago. We said that we can't divide by 0. So this here, this x equals 2, is where the bottom is 0, right? If I plugged in 2 right here, I'd get 4 minus 4 is 0. I'd be dividing by 0, and that's bad. So that means that I do not include this point. I'm never going to include the bottom. Never include the bottom. The bottom is always going to be an open circle because I can't divide by 0. I can't divide by 0, so I'm never going to include that point on the bottom. Okay. So when I graph this on my number line, I've got a point, label my 0. I've got a point at 2 and at -1. I said I'm going to include the -1, but I'm going to exclude the 2. I'm going to not include the 2. So how many sections do I have here? How many sections? I've got a 1, and a 2, and a 3. So this is the answer to why do I have to do it algebraically, is, see how some circles are open now and some circles are closed? You've really got to think this through. And if you don't solve it algebraically, as the problems get harder, you're not going to know which 0 is associated with the top and which 0 is associated with the bottom. So you have to do this algebraically and think it through to make sure you're going to do it right. Okay. This is at the point where if you're not doing it by hand, at least the first part by hand, it's going to be really, it's going to be really obvious. So I'm going to label my 3 sections because I'm consistent, and then I'm going to graph it. So I've got, that's what I meant, 3x plus 3. I'm going to make sure I use my parentheses. The other nice thing about doing it algebraically first is that if you do something stupid on your calculator, it'll be pretty obvious. Alternatively, if you do something stupid algebraically and then you graph it, your graph's not going to match. Basically, if your graph doesn't match your algebra, it means you've either done your algebra wrong or your plot wrong. So, you know, if you forgot to put parentheses in your graphing calculator or something, it kind of gives you a double check on it, which is kind of nice. So can you see my four, how many sections I have? 3 sections here. I got this section, and I've got this section, and then here's my 3rd section. So I've got an above the line section, a below the line section, and an above the line section. So I've got an above the line section, and a below the line section, and an above the line section. We'll say, well, how do we know this doesn't cross down here somewhere? Well, we know because if it did cross, we'd have a 4th section. Okay, so does that look mostly kind of sort of like what we're doing here? I know the graph's ugly that I did, but it doesn't really matter as long as we've got above the line, below the line, okay. Okay, so we're looking for greater than 0, right? Looking for greater than 0. So do I include this first part? Yes, I do. And what about the middle section? Do I include that? No. And what about this last part? Yes, I'm going to include all of this because it's above the line. And I've already taken care of open and close circles, so my brain has actually been off for about 15 seconds, which is great. We love it when we can turn our brain off. So I'm going to go from negative infinity to negative 1. Include the point, because I already figured that out earlier when I was still fresh and thinking about stuff. And then from 2 to infinity, but I don't include that point. And I'm done. Done that part. So these really aren't that bad. Sometimes they'll do you a favor. And by that, I mean they will actually factor it out for you in advance. So here's another example of why it's important to do this by hand. Got this. So remember, I'm going to look at the top, and I'm going to look at the bottom. So I've got that on the top. And it's already factored, so you don't even have to think for a while. It's fantastic. So that means x minus 5 is 0, or x plus 3 is 0. So x is negative 5, and negative 3. Oh, sorry. That was crazy. X is positive 5. X is equal to negative 3. And here x is equal to negative 7. Now on the top, am I going to include these points? Yes, I'm going to include these points because of the equal sign. And what about on the bottom? Not included, right? I never, ever, ever include anything on the bottom because I don't divide by 0. Don't divide. Divide. 0. It's not my thing. So I don't even have to pay attention to what the actual equation looks like for a while because all I have to do is plot this on number line. Number line. Got a 0 and a 5 over here, and a negative 3 and a negative 7. And I include 2 of them. I include this one and this one, but I don't include that one. And let's see. Good. Now I fill in that line so I remember what I'm doing. How many sections do I have? It's a very important question. How many sections do I have? I have 1, 2, 3, 4. I have 4 sections. Remember that. I have 4 sections. How many sections do I have? 4. You have 4 sections. I do have 4 sections. So now if I go graph this thing over here, I have x minus 5 times x plus 3, oops, over x minus x plus 7. I'm going to graph it. And this is why this is important. Because say you didn't do this in advance because you're like, this is dumb, I don't believe her, she doesn't know what she's talking about. Well, aren't you in for a shock? Because what's happened? How many sections does it look like I have right now? Be honest. I know you know what the answer is, but just pretend you hadn't actually done the work. How many sections does this look like it has? 3, right? It looks like it has this one, and that one. Section 1, section 2, section 3. How many did we say it had? 4, right? We said it had 4 sections. So where's our other stupid section? This is why you have to do this in advance, because otherwise you'd just say, oh, there's 3 sections, and you think you were done, you get the problem wrong, you're like, I graphed it, the problem was wrong. Well, that's because you didn't actually do what you're supposed to do. All right, I'm getting kind of, actually, it's 9:30 in the morning, I don't know why I'm tired. I just must feel feisty today. So, if you do not see as many sections as you have, it means there's a missing section. And that doesn't mean that your calculator is stupid, it means that you just need to look for it. So I'm going to zoom out, see if I can find it. Oh, there we go. And there it is. Look at that. This little extra piece showed up. This is important. That's our missing section. So if you're not doing this by hand, one day you're going to get a problem that's not going to be nice. So we've got our missing section. We have a section down here that does something goofy. Right? Got our stupid section over there. Now I'm going to go back to the regular picture. Our next section is up here, right? Our next section's up there, doing something like that. And then our next section is a loop under, and then we got an arm over. It's got a loop under and an arm over. Isn't that exciting? See why you need to do what I say? It's because I know what I'm talking about. So now we can go back to our, do I use this, do I not use this? So we're looking for greater than 0. This is on the bottom. Do I want it? No. What about this part in here, this second section? Is it above the line? It's above the line, so I want to include it. All right, next section, above the line? Nope, not above the line. What about the last section? Is it above the line? Yes, this section's above the line. So I'm going to include it. And now I can write my answer. Reading from left to right, it goes from -7 to -3. And then it goes from 5 to infinity. And that's going to be your answer right